Welcome, everyone, to preparing for the California Science Test. We're excited to introduce ourselves as you all have introduced yourselves. So I will go first, I guess. So my name is Brendan Finch. My pronouns are he, him. You can X at me, tweet at me at birdbrainfinch. I taught middle and high school in Los Angeles for 7 years for LUSD and KIPP and Green Dot. But I left the classroom almost 10 years ago to build rocketlet.com. And that's an adaptive science reading website. And for the last 4 or 5 years, we've been building Inner Orbit. So part of that work for the first couple of years, I wrote all of the assessments on the site. Now I spend a lot of time, we're building a new sort of like product line. And we have some teachers that are beta testing these new sort of like sense-making tasks. So think informal sense-making, do-nows, and like scaffolded SCP practice that aren't like formal assessments. So I have our formal assessments on Inner Orbit, and now we're building some things. So I'm speaking to a lot of teachers, an admin, and some students to build these new products. And I'm really excited to introduce my wonderful colleague, Julia.
Thank you, Brendan. And hi, everyone. My name is Julia Mota. I used to be a teacher for elementary students in the Dominican Republic and then a tutor. I've been building materials to support teachers and districts with the NGSS with Inner Orbit for the last 2.5 years. And I'm Inner Orbit's district engagement manager. So if you want to pilot, if you want to try Inner Orbit on your own, feel free to email me, shoot me an email, and I'll get back to you. I'm happy to see a lot of familiar faces or familiar names in the audience. So back to you, Brendan.
People are going to be afraid if you tell them you can see them. Be careful. Okay, welcome, y'all. Let's go through our agenda for today and our objective. So we're going to analyze some release test items and then dive into some strategies from our partner at ABC Unified School District. So shout out to Lora Ayala. She is not here with us she's not going to be presenting, but we have an interview we recorded, and we're going to go through some thoughts that she had, which I think are really, really helpful. We're going to be here for about 60 minutes. We might finish early, so look out. Our first thing we're going to do is talk about approaching CAS prep with Lora. She's the head resource person for science at the secondary level for ABC Unified. I have her actual title in a slide, which I'll read to you later on. Then we'll go over some release test items, some examples, and some quick analysis of that. And we'll talk about scaffolding up to 3D questions. Within that section, we'll look at some Inner Orbit assessment items, talk about the partnership that ABC Unified has had with Inner Orbit and is still working on. We'll probably work with them for a little while. Talk a little bit how they're using our items for the LCAP data. This is all kind of like layered on top of items for test prep. And then we'll talk about other ways to use phenomena for test prep. So what we hear some folks doing are giving just formal assessments for preparing for the cast. And we want to provide some additional ways that you can think about using, items that aren't just, an assessment, like using phenomena threaded unit, talking about do nows, or these SCP practice problems, which are these problem sets that we've built within our Inner Orbit platform so that teachers and students can have practice with just the SCPs. Now, I know if you are an NGSS fanatic or a purist, that the DCIs and SCPs should always be used together. So the SCPs are practices to be used with that. But the practice problems are just that. They are practice problems. They are not assessment items. You should not pull data from them. So we're really excited to talk about that. We always get really interesting conversations in the chat. Please make sure you click everyone on the chat so that everybody gets to read your thoughts and your questions and your responses. If you just send it to host and panelists, Julie and I love hearing from you, but we want everybody to hear from you too. So welcome y'all and started. Julia, you ready? Okay. Be careful with the thumbs. We updated our Macs, and if you give thumbs up, there's fireworks and stuff that appears. So we have to be really careful with the thumbs. There they are. Okay, cool. All right. Anyway, so to kick everything off, we'll talk about what Inner Orbit is, to give you a little bit of background on what we do and how we do it. So the first thing that we provide are phenomena. So you probably already know this, but the NGSS is aiming for students to be looking at things they've never seen before. And we want them to, instead of memorizing information, to apply learnings from one thing to another thing. And so that process is called sense making, and it is necessary to have novel phenomena. So students can take their knowledge and apply it to something else to explain why or how something is happening. We also write a bunch of very, very specific and particular types of questions, which we'll go over later on, to help scaffold up to that. The big idea is that you can pull data from what students know, maybe how they apply that with an SCP or a cross-cutting concept or a three-dimensional performance, and use that data to make decisions. And that data comes through in our reports. This is a screenshot of our dimensions report, which breaks down SCP, like developing using models, and it breaks it into its component. So grade level bands. So we're looking at 3.5 and 6.8. It's a whole bunch of scribbles on this report. But essentially, we're looking at each of the elements within that grade level band. So in 3.5, there are 6 different performances that we're looking for students to show proficiency on and to grow towards. And for 6.8, there are 7 different performances. And so students have to do things like, develop and use models to describe or predict phenomena, or they have to develop a model to describe unobservable mechanisms. So things, where the time scale is so great that we can't possibly observe it, or so short where it's impossible for us to perceive this change happening. And so those are all specific pieces of the standards that are tagged to questions. So we write questions to one of those things. So we don't have questions that are just tied to an SCP, but to a very discrete element of that SCP so that you can have data and make decisions with that data. Cool. And I'll show you the reports in a little bit. If you want to learn more about Inner Orbit, if you want to meet up with Julia, it's Julia who you're going to be talking to, then you can click on that link that is in the app right now or in the description of this video. And if you want to start a pilot on your own, you can also click on that second link, which says start a pilot on your own. So you can click there and get started. So if you want to talk to Julia and have her walk you through the platform, then click on the first thing. If you are like, I don't want to talk to Julia at all, then you can just click on the second link. You can go to the website and explore on your own. Cool. All right, here we go. So now we're going to talk about past practice items and do some analysis. And we're also going to hear from our partner at ABC Unified. So this is Lora. Lora, everyone, Lora. So Lora is the 612 program specialist for science and health at ABC Unified. They're one of the California partner districts for Inner Orbit. So we're really, really excited to amplify her voice. And while you listen to Lora talk, I want you to think about a couple of things. So first, I want you to think about how is the cast framed around the NGSS? So we have the pleasure of working with folks in many, many different states that have assessments. And Lora is going to share some of her thoughts on how the cast is related to the NGSS. Now I want you to think about what opportunities they structure for teachers to give students, and then maybe when, should these strategies be used? And without further ado, let's let Lora talk a little bit more about how we should approach preparing for the cast.
When I'm thinking about cast, I'm approaching it as something that we can learn from because it's a reflection of NGSS. Understanding cast really is going to give us insight on how to design NGSS performance tasks for our classrooms and really focus on implications for instruction. I also think that some people, when we're thinking about preparing for the cast, they're thinking, I want a quick fix. I want a one-day review, or I want a week long to cram before the test. And especially because we're looking at several grade bands, but preparing for the cast really begins from the first day of instruction or even before that. So I feel like preparing for the cast starts with solid instructional practices and really grounding in what NGSS is and understanding NGSS instruction. And what's interesting is you can't really pull out assessment from that. So assessment is part of the instructional cycle. So I think just expanding from preparing for the cast, you can't separate instructional practice from that. And so it's kind of like a circular answer. We really need to ground ourselves and run the marathon, not like a short race, a strong foundation.
We'll hear more from Lora in just a little bit. And now I'd love for you to just consider in your own context some of these reflection questions. And if you would like to reflect in the chat, we would love to hear your responses. It's really, really interesting to hear just how folks are thinking about this through their lens. And so how are you approaching cast prep in your context? So some of y'all listed things in the chat earlier. So people mentioned that they're using the California interim assessments. Some folks said they're using the Illuminate or formative item banks. Some folks said they haven't yet been doing that, which is excellent. Start now, now's the time. And then I'd love for you to also reflect on, thinking about what Lora said, where we're running a marathon, not like a short sprint to prep for that. I don't know if any of y'all have run a marathon before, but if you just run the couple of weeks beforehand and then you jump into the 26 miler, it's going to be rough times for your toenails and probably lots of other parts of you as well. So what are some of your thoughts that you have in the chat around how you're approaching cast prep in your context? And then what are some next steps that you might take given where your school or district is now? So maybe right now we're using, the interim assessments, and next we're going to build common assessments, or right now we're just preparing our own things, and what we're looking to do in the future is develop these larger summative assessments. So I'd love to hear just kind of the things that you're thinking about doing now, or what you're doing now, and then also what you would like to do next in your context. So I'll give you a minute to respond in the chat. And I do see somebody responded in the Q&A that they're using interim prep assessments, and they're coupling activities with low floor, high ceiling protocols. I'd love to know more about what low floor, high ceiling protocols are, if you'd be willing to share those. So I'm seeing in the chat that folks are really focusing on NGSS instructional practice all year long, which this is clearly the message from Lora. And if you've done this work within your classroom, school, or district, you know that students don't just right away, have the ability to make sense of novel phenomena. It's tough. It's a challenge. And so I saw somebody in the Q&A also mention that low floor, high ceiling protocols are things that allow students an access point. Okay, thank you for specifying a little bit further. So I see somebody said things like notice, wonder, reminds me of, which one doesn't belong, I squared, or identify and interpret. So it's just sort of open-ended prompts for students to be able to sort of like become familiar with ways to think like a scientist and to look at something new and sort of like pick apart or notice and wonder and make observations that are structured. Is that an accurate interpretation? I see there's a question in the chat sent to hosts and panelists. If you don't mind changing the little blue pill at the top of your chat box, right above where you type to everyone instead of hosts and panelists, folks will see. But somebody just asked, how are people breaking them down, referring to the interim tests being long? How are you breaking them down into, all good. How are people breaking them down into smaller chunks? So how are y'all taking those interim tests and implementing those with teachers? And just to respond, so there's somebody in the chat who mentioned the low floor, high ceiling protocols, and they said the cross-cutting concepts where students make sense and find parallels. In our last webinar, so last week, we presented with a group of teachers, or with a teacher leader in Connecticut. And she had a physics teacher, who used waffle makers as an example of stability and change with their students. So scaffolding that cross-cutting concept of stability and change. And what they're looking to do are provide these protocols for students to be able to think about things like, what keeps something stable, and at what point do things become unstable. And so a waffle maker, I feel like, was a really good example. And all of their students had many thoughts about other things they could have used, like a panini maker, which seems like a even more off the wall example. But the waffle maker is really interesting because, there's heat, there's time, there's the amount of, like waffle batter that you put into it. And everybody that has used a waffle maker has had the experience of putting too much batter in it, because that's just like an engineering flaw in those things, is that you can never see how much you're putting in, and then all of a sudden you have a mess. And so it's a very interesting way for them to approach that. And then they had a lab where stability and change was the focal point of the lab. And they used their sort of like understandings from the waffle maker example to apply to the lab, which it sounds like is very, very similar to what you're talking about there. So think about waffle makers or something else that's more culturally relevant to your kiddos. Awesome. So just in the chat, there was a question earlier. How are people breaking the interim assessments down into smaller assessments for teachers to be able to have better access to, so they're not like super long, big, gnarly things? So if you have an answer to that, I'd love to hear it. But to be good with our time, I want to make sure that we're still rolling and we're moving forward with this. Thank you all so much for your comments and all of your questions. This is fantastic. I really, really appreciate it. Cool. So I'm going to roll on and make sure that we've got some test item analysis for us to go through. So here's an item from the California practice test. That's an 8th grade item. And what it asks students to do is gives them some data on the small fish that live in these shitty ponds. And some of the small fish are light colored and some are dark colored. A new predator is added to the pond. And one of the primary food sources is the small fish. And the table shows the percent of each color of fish in this population before and after the predator was added. So we can see pretty clearly that there are some new environmental pressures being added into this ecosystem, or this microecosystem, if it's just a pond. So based on the data in the table, select the best phrase from the menus to complete each sentence. And so I highlighted that and just showed you what the possible responses were. After the new predator is added to the pond, the blank have a better chance of surviving than fish of the other color. This is because the better predator blank. And so you're intended to, pick the pieces of this that fit best with that. And so what I'd love you to do in the Zoom chat is to think about this. So with the old CSTs, questions like this didn't appear, but I'd love for you to think about, how are students applying their understanding of natural selection to make sense of this phenomenon? The CST, it was much more, like we're gonna memorize things and you're gonna know all the parts of the cell. Now think about, how are students applying their understanding of natural selection to make sense of this phenomenon? And go ahead and type your answer into the chat. I struggle so much with teacher wait time, and so I'm gonna go ahead and and pick this up and we can keep on moving on. But I see somebody responded that changing and comparing the correlating changes in values after that new predator is introduced, looking at evidence for why certain fish are able to survive based on their attributes. And namely, in this case, there's light and dark as the only characteristic that we're able to, that we have data on before and after the new predator. Yeah, that's exactly right. And so I guess, is this a problem that students could memorize and then be able to just answer off of their memorization? And the answer is no. So students need to understand, they need to be able to interpret data, and they need to be able to apply that understanding of how natural selection works and how some predators or some environmental pressures may cause some groups of organisms with specific traits to be more successful or less successful. And in this case, it's getting chomped on by this new predator in this shady pond with a dark bottom. So let's move forward, and we can look at some three-dimensional standards and kind of see how maybe we can scaffold up to a question like this, which this is a tough question for students to just get off the bat. So let's look at our 3D standards and think about how we might scaffold up to questions like that. First, I'm going to call your attention to what the standard is that question is referring to. So this is MS LS44. So it's a middle school life science performance expectation, where students need to construct an explanation based on evidence that describes how genetic variations of traits in a population increase some individuals' probability of surviving and reproducing in a specific environment. So that is the performance expectation. And below that, there are 3 dimensions that come together in this. So we see constructing explanations, where students have to construct an explanation that includes qualitative or quantitative relationships between variables that describe phenomena, and also natural selection, that's the DCI, the content that students need to understand, and cause and effect. So phenomena may have more than one cause, and cause and effect relationships usually can be described with probability. So we can look at probability as a way to describe, what is happening. Cool. So that 3-dimensional standard involves that what students know, that's the DCI. And then we also have the what students do or what scientists do, usually in analyzing or communicating or taking in information. So those are the SCPs, in this case, constructing explanations and designing solutions. And finally, there's a 3rd dimension, which is the cross-cutting concepts. As mentioned in the chat, those provide a really interesting lens for students to be able to engage with things. They're a very accessible lens for students. How students think is one of the ways that this is phrased by the authors of the NGSS. I like to think about these as lenses that students use to view and sort of like analyze phenomena. So, what patterns do I see here? How did cause and effect come into play? At what scale do I have to observe this system in order to see what's going on? We find more and more that teachers are asking students to explicitly call out and describe the cross-cutting concept that they're using in their analysis of a phenomena, which I think is really, really interesting. And as somebody mentioned in the Q&A earlier, that it can provide some great access, the low floor, high ceiling activities, which I think is a great way to refer to those things. So with that question that we just looked at here, so students have to construct a qualitative, relationship, and they need to build that understanding. And it's all going to be centered around the idea of natural selection, that some traits are going to be more successful than others due to environmental pressures, and that we'll have to look at cause and effect. And so how specific causes can be attributed to specific effects. In this case, the introduction of a new predator that, is only seeing specific types of fish. And so these are the types of phenomenal questions that we want to build students up to, and they incorporate all 3 dimensions of those standards. And now I guess the question is, okay, so if this is what we're going for, how do we get kiddos up to that point? Because that is not simple work. And so what I want to present you with right now is some examples of how we might think about scaffolding from representation to sense making. And before I dive into how we might scaffold from representation, that's understanding of ideas, to scaffolding or to sense making, which is applying your learning to make sense of a novel phenomena. So those are the 2 things we're looking at. I'm going to allow Lora to speak a little bit more about how she approaches assessment and her partnership with Inner Orbit. And so when you listen, I'd love for you to focus on considerations when evaluating NGSS tools. So all of you that are here, many folks that are present, I know, are leaders at their schools or districts, or teacher leaders as well. And so these are things that you are most certainly thinking about as you're evaluating different tools. How are Inner Orbit's questions and reports helpful to Lora in her context? Thinking about common assessments and ways to get groups of teachers to build assessments and then reflect on that data productively. Make sure that, as much as possible, that we can level the playing field and allow us to see, where there are strengths, and we can lean into those strengths, and where there are areas where teachers or students need support. And then 3D data chats, which is really, really interesting. I'm excited about this. I get to go, physically to Cerritos and help to facilitate these data chats with their teachers, because we do a lot of professional learning in addition to our actual assessment items. So let's let Lora talk a little bit more about how ABC Unified approaches assessment in partnership with Inner Orbit. And with that, I'll let Lora take it away.
In NGSS is really important. So strong foundation in NGSS is really important. So without that, all of the rest of the work is going to be a challenge. Make sure that anytime we're adding some type of a tool, we're not going away from that best instruction with NGSS. So any type of simulation or assessment platform, it has to still have the heart of NGSS within it. It's not going to be like fluency type of a thing or making sure that we know quick facts. It really has to be aligned with the heart of NGSS. I was searching for a tool that could really help our teachers see examples and have options for NGSS assessments. And when I came across Inner Orbit, it felt like a natural fit. And then speaking with you, Brendan, and working with Aaron has been really helpful for our district because we were able to partner with Inner Orbit, and that, going from there, we have had a lot of success with our data analysis. Before using Inner Orbit, we were doing a common assessment, but one thing that I really wanted to mention was the assessment tool really matters. We were giving a performance task that was three-dimensional. We understood what NGSS assessment looks like. We understand it needs to be three-dimensional. It was scaffolded. But if you can't pull the data to help you see how the kids are doing in the 3 dimensions, you can really only get so far with data analysis. So I feel like working with Inner Orbit and the data that we can pull has been really helpful for us, because we can really not only see really discreetly how the performance task is scaffolding to 3 dimensions, but also it's helping us to be able to see how the student is doing in all 3 of those dimensions. And one thing that I want to make really clear is it's a 3-dimensional assessment. So even though you might see a piece of that standard, like one question might get to one part of the standard, as a whole, we have a great performance task that's still 3-dimensional. So we're not trying to break apart the standards in any way. It's a really holistic approach. So I think that that's really helpful for the students. And then also, it's been wonderful to look at how can we expose students to novel phenomena, and how can we help teachers to just have these tools so that they're more accessible. So that's been a really big success. So another thing that I want to mention, we started with having 2 courses do common assessments previously to Inner Orbit. And this year, working with Inner Orbit, we had our common assessment team actually come together. We grew that to 5 courses doing the common assessment. And Orbit was able to help us really design something that could target science and engineering practices. And I think that designing the assessment was really insightful, but also just the data chat after. So also continuing to partner with Inner Orbit and have the data chat so that we could even get more out of that data. That's where the meat of this partnership has been for us, because we were able to see just through the discussion how the students were doing. We were able to see a couple blind spots of our understanding of NGSS. So teachers can further their understanding of NGSS. And then also the student impact will be that teachers were able to pinpoint specific science and engineering practices to continue to address that instruction, and then use Inner Orbit after reteaching, go back and give another assessment.
Thank you so much, Lora. So we're really excited to be able to partner with ABC Unified, and we actually help them to build these assessments, and their common assessment team also comes together and then pulls from our bank of questions, which at this point is, I think very, very soon will be over 10,000 items from grades 3 through 12. And so they're able to pull that data and build those assessments in there as well. And later on, I'll walk you through the reports if you haven't seen them already. You can think about that. So what I'd love for y'all to understand, or to communicate and chat about, because I think this is a really, really interesting point, and something that in my own practice as an educator and as a science department leader was really, really powerful, were common assessments. So I'd love to hear how y'all are using common assessments in your context now. In addition, what are some opportunities for next steps in your context? So are you leveraging those interims, and is there data? I heard a lot of people, or saw a lot of people talking about the interim assessments. Is there data that you're pulling from those? The other platforms that you're using for assessment, are there ways that you're implementing those common assessments? And is there data that you're pulling from those that helps teachers to have productive conversations. And so I'll give a minute for folks to respond in the chat. I think it's wonderful to be able to have, ideas that are shared between everyone so that we can all approach this in different ways. And thank you all very much. I really appreciate the responses in the chat. I'd also love to know, how the sort of like data chat conversations are happening after those common assessments. It'd be really, really interesting to see, like how folks are leveraging that assessment. So obviously the implementation of common assessments is a logistical challenge in and of itself, but then also the, what happens afterwards is, arguably the most important part outside of just getting the data. So I'd love to know how y'all are going through those data chats after teachers implement and students, go through the sort of like benchmark or interim or common assessment. Those regional data days sound fantastic, Porvi, because it sounds like you may be pulling teachers from a wide variety of different schools. And that way you can have those conversations across many different school sites and see very clearly where there are strengths and where teachers and or students need more support. Fantastic. Love hearing there's a data analysis protocol that's in place and there are intervention and extension days that the teachers plan. Maybe those are even calendared as re-engagement. That's great. Monthly meetings with teachers, fantastic. I think this is one of those things, it's difficult to say we're going to take away instructional time, but obviously the more time you pour into preparing teachers for efficient instruction and giving them the data to make good decisions, that's going to pay dividends considerably in the future. So I love that. I know it's an investment to pull teachers out of the classroom, either for days where they're going to be subs or to say, hey kiddos, like you're not going to come to school today. The teachers are going to come to school with each other and learn and analyze that data. That's great. It's wonderful to hear that folks are have scheduled PLC time and data analysis time, because I think that is one of the most important things in all of our work with many, many districts across the country, where we find folks getting further faster because teachers sit down and you can easily exchange best practices and easily see where there are gaps across an entire system or an entire district or a school, except, maybe there are one or two places where, scores are higher and those folks can share some insights. Or as a leader, you can plan professional learning for those groups of teachers. If you see that, there's an area where there's maybe a misunderstanding or the implementation is missing the mark a little bit. And so the assessments are showing that there are issues with that. Awesome. Cool. If you're still typing a response, don't feel like my moving on is a dismissal of your thoughts, but we'd love to hear what you have to say. And with that, I also want to go into, kind of like how we think about scaffolding for this, because those performance tasks are a great way to see that final performance. How are students doing, at the end of things? Because that sense making is really an end goal. So we want students to use their knowledge through the lens of the cross-cutting concept and the SCP to explain why or how something is happening. But I guess the question we want to pose and then immediately answer is, how could we scaffold students up to this point? And then also give teachers data to reflect on that. So we at Orbit like to think about the invisible steps that we're asking students to take and then gather data on each of those, invisible steps to best support them. So what we want to, talk about is how maybe we can move students from the position of representing their knowledge, so that DCI only understanding. So think of the old science test, the CST, where students just know things and they just communicate, the nucleus is the brain of the cell or something like that, to a three-dimensional understanding where we say, here are the inputs and outputs that we see from, this organelle or from this system or from this tissue. Use your understanding that you have to explain why or how this thing is happening here. And so that three-dimensional understanding, that sense-making understanding, which is an abstraction of that knowledge in application to this new phenomenon. And it's always going to be around something new that they're seeing that can be explained with scientific knowledge. And so with that, I want to present one of the in-orbit phenomena, which is why did these moths morph? Our team has been really into alliterations lately. And so you're going to find all these weird alliterative phenomena titles. So this is all about moths. This is like a very, very famous phenomenon. I'm not going to read all of these things. This is looking at the change in peppered moths rather than looking at it at the, like the start of the Industrial Revolution, seeing how things have changed recently. And, you may know that there are much more efficient, systems for processing and for pollution. And there are, laws and regulations that have been put out so that you can't just like pump coal and soot and things like that into the air, which is wonderful. to some degree that has been mitigated. But with that, it's been mitigated to the degree that, some of these moth populations have actually recovered, and there have been shifts in what traits have been most successful. And so going from the dark colored to the light colored moths flipped over time, which is really, really interesting. And so we look at those two moths, we look at the changes in peppered moth morph frequency as well. And then we'll ask a summative question. So on in orbit, we call our three-dimensional for response questions sense-making questions. And so this question says, use your knowledge of natural selection as well as evidence from figure 1 and 2. So you need to pull evidence from these quantitative representations. Construct a scientific explanation about why the peppered moth population has changed so drastically during different times in history. Be sure to include a discussion of the factors or variables that caused the change and how they impacted the population. We give students some background in that phenomena that they can pull from, but they need to understand that underlying sense making. And really that's constructing explanations. They need to understand natural selection, and they have to be able to apply, cause and effect to explain why these populations would change over time. What cause would be associated with that effect? And so this is a rigorous question, as is the question that we looked at earlier, where it was the small fish in a dark pond cast question. And we want to think about how we can get students from that representation of the knowledge to that three-dimensional sense-making question. And on inner orbit, our answer are two-dimensional questions. And so we can ask questions about the DCI and the cross-cutting concept to sort of isolate those two dimensions, or we can ask questions about the DCI and the SEP. And these can be ways for us to, give students questions that approach that, sense-making, rigorous three-dimensional question, but still give ways for teachers to collect data. Because if you don't answer that, free response question, you don't really get any data. Students just say IDK, or if they don't provide, a really thorough response, you don't know what they missed. And so what we want to do is identify where, where students need the most support, or where teachers need the most support, and then be able to apply, resources in those areas. So the first type of questions that we have on our site just focus on the DCI. We call these core content questions now. And those are questions that just focus on the DCI. So do students understand natural selection? So this question reads, organisms with traits that are not fit for their environments are less likely to, and we want them to say, survive and reproduce. If you're not fit, then you're probably not going to be able to survive or reproduce. So in this question, we're not asking about instruction explanations. We're not asking a cause and effect. We're just saying, do you know what this is? Do you know what fitness is and how that is applied in the context of natural selection? And so if students answer questions like this, that's great. Then we can sort of like up the ante and ask them questions that are more complex. And so one of the other questions that we have in site are called content and practices. So we like to think about this. Once we've validated that students have that knowledge, maybe you can apply that through the lens of the content and the practices, the SEPs. So in this case, we're asking students about consider the moths in figure 1 and the trees that they're currently resting on. Which moth would likely be eaten first? So I want them to be able to construct an explanation based on, so it's qualitative evidence, since that's what the constructing explanations here. This isn't just a CER statement. It's being able to explain things with qualitative or quantitative evidence. And so in this case, we're not looking for data on the cross-cutting concept of cause and effect. Instead, we want to look at just their ability to construct an explanation using that qualitative evidence or data, or quantitative evidence or data, and understand, the concepts of natural selection, and that some of those moths can be better suited for their environment rather than others. And then we can also ask questions that are two-dimensional and hit the cross-cutting concepts, or the concepts and the content and the concepts. These are our other form of two-dimensional questions. And so we could say, suppose a logging company started cutting down trees in the forest. Which moths would be most affected? And so we want students to understand the fact that, both the light and the dark colored moths use those trees as places for them to camouflage and to rest. Maybe they're taking a nap there or something like that, and that they would both be impacted by this. So we're looking at cause and effect mechanisms, not constructing explanations, and not using that qualitative and quantitative data, but just understanding that there's a cause and effect, that if we made changes to the entire environment and all of those trees, that all moths would be affected by those things. Then we can also ask the three-dimensional sense-making questions. We have multiple choice questions as well. Hit the SEP, the DCI, and the cross-cutting concept. So we'll ask things like, refer to figure 2 if a new type of dark tree started to grow in the forest. How would you expect this to affect the number of dark and light moths? So this is very, very similar to the question that was asked on the cast, where we want students to be able to identify dark moths would increase because they can camouflage better against this invasive darker tree, as with the fish in the dark pool. Awesome. And so with Inner Orbit, what we're looking to do is provide data on all of these different steps. And so giving data on what, core content, what DCI elements students are struggling with or being successful with, and then the, parts of the content and the practices, or the content and the cross-cutting concepts And then also three-dimensional questions that focus on sense making. And so with our reports, we have really, really robust data. So this is our website, and you're able to look at things like the DCIs and see what elements have come from, the 3-5 grade level band of those DCIs, or the 6-8, where students are having greater success and where students are struggling. So each question is tied to just one of these elements, not the entire suite or performance expectation. And for things like the SCPs, we want to look at not just our students, planning creative investigations, but are they able to evaluate the accuracy of various methods for collecting data? Are they able to collect data to serve as the basis for evidence to answer set questions? So basically a TR statement at the end of a lab or an investigation. And so in this way, we're looking to not just say, okay, students are doing well on an SCP or on a performance expectation, but we can break down maybe the struggle is not with the SCP, but it's with energy and matter flows, and specifically the idea that energy drives the cycling of matter within and between systems. And so this is the level of detail that we're looking to get to with our reports, so that when teachers come together and they sit and they look at data, they're not just saying, it's the cross-cutting concept of stability and change, but they can say with much, much greater specificity, these are the things that have been, successful, and these are the things where students need greater support. If you're supporting teachers, then you can plan on professional learning as well, which is another thing we see folks doing within our orbit. Great. So the LCAP is an important part for some of y'all in your role. If this is something you need to do, then I'd love for you to listen to Lora talk about this a little bit more. So they use the in-orbit data in goal planning for the LCAP. Some of the things I want you to consider are, what are some questions that Laura's asking about the data? What data are they able to collect, and how are they using this in their goal planning? And so with that in mind, let's listen to Lora talk a little bit more about the LCAP.
In our area, we have our local control accountability plan. So having the data from inner orbit is successful for us because we can add that to our LCAP and be able to say, I would like to address this or this, so I need funds for IPD or those types of things. So if you're able to show mastery or lack of mastery in a different area, it helps to further whatever your goal is. So if you can identify, I'd like to further this area of understanding with my teachers, or students are not succeeding according to this assessment, students could benefit from their teachers developing a certain understanding or skill. You can add that to your LCAP and have some data to show it. So right now, we're currently at the end of our third year LCAP cycle, and we're doing mid-year review. So I'm currently kind of thinking about moving forward, how can I use inner orbit as a way to see if we're on track for some of our goals? So because this is a new tool, I'm thinking about for the next 3 years, what are our goals for our district, and how can inner orbit show if we're on track for those goals, and how can inner orbit help us to make adjustments to make sure that we're having the right goals. Do we need to adjust? And so let's say that we plan for PD for a certain thing, but then in our data analysis, we realize, we actually really need to go back to cross-cutting concepts because in our data chat, it was a little bit unclear. So it kind of helps to inform with making goals and adjusting.
All right. Thank you so much, Laura. And so with that, I just want to make sure that we all have data for our LCAP and that you're thinking about all of how you're planning for those goals and how you're measuring progress towards those goals. And now I'm going to pass it off to my colleague, Julia. And Julia's going to talk about using phenomena for test prep. We've been talking about formal practices. So common assessments, interim assessments, like kind of these big, beefy formal things. But what we want to present to you, and what was mentioned in the chat in other places, is that informal practice is equally and maybe even more important to have throughout the year. So Julia is going to talk a little bit about how we can use phenomena throughout the course of a unit or the school year, and some different ways that you can leverage some of the items and phenomena from inner orbit to do that. So Julia, with that, I'll pass it off to you.
Thank you, Brendan. So as you just said, what we want is for students to get used to transferring that knowledge to novel phenomena. So let's review some strategies we could use in our classroom now. And for this, let's go back to our standard, which is MS-LS44. And just to recap, we're asking students to construct an explanation based on evidence that describes how genetic variation of traits in a population increase some individuals' probability of surviving and reproducing in a specific environment. And we've mentioned using phenomena and assessments, but how can we give students more opportunities to make sense of all of the DCIs throughout an entire unit? And what are the different types of experiences we can give them to practice for those rigorous questions? So we've built this roadmap of phenomena that we pulled from the Inner Orbit website that we would use throughout this specific unit. And in the very beginning, we could start discussing how have pupfish adapted over time. And since we're still in the beginning of the unit, we would consider a lower stakes discussion like a whole class walkthrough. And this is all about how we can see a variation of traits in the desert pupfish between different pools within a small area of the desert. And we would include discussion questions that target the CCCs and the SEPs for the whole class to answer together in this initial stage. Now, moving on to the middle of the unit, we could talk about the reason why snail kites and limpkins added different environmental pressures on snails in Costa Rica. Here, we would consider separating maybe the class in groups to answer questions collaboratively in a printed and scaffolded group phenomena exploration. And students in this case would discuss that different predators will apply different environmental pressures to organisms and change successful traits in the population. So students are answering rigorous questions that target the DCIs, the SCPs, and the cross-cutting concepts, but with scaffolding from the teacher and support from their group. Now, in this last stage of the unit, we could assess students by building a short online assessment to be administered individually. In this case, we're looking at the Galapagos finches and how beak shape changes based on available food and other pressures in different parts of the Galapagos Islands. And in this final part of a unit, students should be ready to engage with rigorous sense-making questions. And teachers can still provide scaffolding as needed, but removing those scaffolds is important for building student independence and confidence. So at this point, we have plenty of phenomena for this life science standard. But let's say our students are not there yet, and they're starting at a level where they need even more phenomena and even lower level phenomena to access these rigorous things. So in this case, what we would do, or what we would recommend, is for you to go from the on-grade level standard to a prior grade level standard. Now let's go back to a whole grade level band to this third grade standard, where students have to use evidence to construct an explanation for how the variations in characteristics among individuals of the same species may provide advantages in surviving, finding mates, and reproducing. So in this case, we could first discuss the reason why this caterpillar looks like a snake. And this is all about how some organisms have evolved to look like different animals to confuse predators. And then we could go over the reason why peacocks have an astonishing number of eyes in their colorful tails. And this is to help them attract the attention of potential mates. Now, to sum up, let's review the big ideas of using phenomena throughout a unit. And first of all, practice makes perfect. As Lora said, we should be using phenomena throughout all units, not necessarily only during test prep season. And using different phenomena provides more opportunities for students to model and practice transferring knowledge and sense making. And if students are struggling with phenomena targeting their grade level band, we can always lower the stakes with a prior grade. And we can give further sense-making opportunities and identify possible gaps in knowledge or in skills. Another strategy that we could use with these phenomena, with the same ones that we've just gone over, are these daily do-nows. And these are quick daily activities, it's late, sorry, to review prior standards and or gain experience with novel phenomena. And we recommend building 1 4-question assessment per week, focusing on 1 performance expectation and 1 phenomena for that whole week. And each day's, I think somebody mentioned this on the chat earlier, so each day's question will build in rigor to scaffold students to a rigorous 3-dimensional question by Friday. So students would start exploring and annotating the phenomena on Monday, maybe answering DCI only questions on Tuesday, then moving towards 2-dimensional questions on Wednesday and Thursday, and finally a 3-dimensional question on Friday. Another way that we could use this is in phenomena transfer stations. So this actually came from our work with one of our partner districts in Maryland, where a teacher would print out summative assessments with different phenomena of the same standard for students to explore in groups. So a pro is that students can keep seeing the same ideas from different scenarios, and it sparks their curiosity and helps them make deeper connections. And we would have two-dimensional questions to scaffold students up to a rigorous three-dimensional question or sense-making question. And some things to consider is that in groups, teachers can assign roles. So it's like you would read the phenomena and you would be the recorder, you would find the evidence, you're the fact checker. So each student would have a role, and that's really important. We would also recommend that students need to have a little bit of preparation before they're ready to work together towards this new scenario. So it's best to implement this towards the end of a unit. And finally, we could have a whole class debrief afterwards to make sure you model for students the process of sense making one more time. And finally, on Inner Orbit, we also have SEP practice problems. And these are content agnostic sets of questions that are aligned to the K-12 progressions for the SEPs in elementary, middle, and high school with interesting and relevant phenomena, intentionally leaving out the GCIs and the cross-cutting concepts. And this has been a lot of information in just under an hour. So I'm going to pass it over again to Brendan and Laura to wrap up our webinar with some next steps.
Cool. Thank you so much, Julia. So Laura's going to wrap us up and talk a little bit more about how she's thinking about responding to common assessments. What are some other uses of Inner Orbit that her teachers are using, not just, like preparing for the cast, but how are they leveraging these items? What adjustments are being made to their common assessments? I think one of the things that I respect so deeply about Laura and her approach is that it's very iterative. And so they go into something and they try it out and they look at the data and they make adjustments. And then I want you to also think about this teaching the test, which is something that I think we used to hear teachers talking about a little bit more, and it's a little difficult with the cast. So let's go to Laura for the last time before we wrap up and hear just a couple of thoughts that she has.
So I think the plan is for teachers to use their common assessment data to impact their instruction is really the big takeaway. And a lot of teachers are using Inner Orbit for other assessments and offering retakes so that students can kind of have a growth mindset. And our next steps will be to bring the committee back together and consider, is there any tweaks that we want to make for our assessments. I'm also going to be looking at the CAST interim assessments just to see if we can learn anything from those assessments. And I think, one thing that I'd like for folks to consider is just that the nature of NGSS and CAST is that you can't teach to the test. So there's going to be novel phenomena students haven't experienced. So exposing students to three-dimensional instruction and assessment and novel phenomena and even technology that is true to NGSS is going to really take you further doing that throughout the year than trying to cram for the test. And just remember that CAST measures several grade bands, so it's not just one teacher's job to prepare the students.
Awesome. Thank you so much, Laura. I think those are wonderful closing thoughts. And with that, let's wrap it up, y'all. So we did a lot. It's not Valentine's Day yet, but just like Russell, you deserve some chocolates. I hope you have access to that wherever you are. We did a lot today. And just to finalize, if you would like to try Inner Orbit out, we would love to have you find a time in our calendar to set up a pilot. We offer free pilots, and we'd love to have you try out the platform. You can also sign up for a trial account on your own. If you go to innorbit.com, you're like, I don't want to talk to these people, then that's fine too. You can follow us on social media. Our YouTube channel, we post videos fairly often. This video is going to be on YouTube very, very shortly. Or you can send us an email at inquiries@innorbit.com if none of those other things are things that you want to do, and we would love to hear from you. Thank you all so much for being here. We are grateful for you. If you have any questions, we'll hang out for a few minutes and answer questions. But otherwise, hope you have a beautiful rest of your day. And we're grateful for you being here to grow your practice and think about some of these new ideas or return to them if they're not new for you. And also, for building up everything that you're doing for the students and teachers that you work with. All right, y'all, have a beautiful rest of your day.